Just as a mountaineer climbs a mountain because it is there, so a good mathematics student studies new material because it is there. Here is new material for you. Material is about integration. Now, where did this integration come from? Basically, anything in mathematics arises out of the efforts of the solving problems. Mathematics is about solving problems. So there were two kinds of problems. One, the problem of finding a function whenever its derivative is given. See, we have already done derivative, so we know what derivative meaning. So it's a derivative was given and we are asked find the function. That gave rise to indefinite integrals. At the same time, we have another kind of problem, finding the area bounded by graph of a function. Your functions can have graph in any shape, and then you want to find the area between the graph. So that kind of problem led to find definite integration, right? So the integration arises out of the efforts of the problem solving problems of these two types. Now, when you look at the word integration, what is the literal meaning of the integration? Integration means unite, to bring together parts to make a whole, right? It's like integration. You can consider a family. You come across a certain individual, you ask him what is his name, or you want to know something about him, and then you also want to know the all people of his family, so you want to bring his entire family together. That is the process of integration. Integration means unite people, unite things. Here in mathematics we will say unite the functions, right? So uniting the functions together is integration. Here we will say, we'll define it in another way. We will say the integration is the inverse process of differentiation, meaning whatever we did in differentiation, we will do just opposite of it. Just like addition is the inverse process of differentiation, multiplication is the inverse process of division, we have integration, which is inverse process of differentiation. And integration is also, because it is inverse process of differentiation, so it is also called anti-differentiation, and sometimes you also call it primitive. We would like to understand integration with an example. We said we will be given a derivative of a function and you'll ask what is the function. That's what is the example here. You are given the derivative of the function f dash x. We write derivative as f dash x. That is given, and we are asked what is fx. So, well, if f dash x is given, how will you find fx? Using our intuition about differentiation that we have already learned. We have learned the derivative of x squared. Derivative of x squared will be 2x. Now, what does it mean? It means antiderivative, inverse process. Antiderivative of 2x will be x squared. Should we write here? Antiderivative. Derivative of x squared of 2x. 2x is equal to x squared. That's what we are going to write. Okay. Now, is it the only function whose derivative is 2x? Let's take another example. So we are going to differentiate dy dx of x squared plus 1. Now, what is the derivative of this function again? X squared derivative is 2x and derivative of 1 is 0. So this is also 2x. 2x plus 0 means 2x. So that means antiderivative of x squared, antiderivative of 2x is also x squared plus 1. Haven't we got two members? Member 1, member 2. Similarly, we can take another function, say derivative of x squared minus 5. We would like to know what is the antiderivative of this. Again, we get 2x minus 0, because this is a constant and derivative of constant is 0. That means antiderivative of this 2x is also x square minus 5. How many such functions you can take? Now I think you must have understood. We can take actually infinitely many such function by simply taking different constant number with x square, either adding or subtracting them. So what we can say is, we can say derivative, we can generalize it, and we can say, well, that means derivative of any function, say x squared plus c, where c is any real number, will also be 2x. Hey, can we say antiderivative of 2x is equal to x squared plus c? Yes, where c is a real number, which is called arbitrary constant. Arbitrary means we can take any real number. So c is a constant, and that means there are infinitely many real numbers. So that means there are infinitely many antiderivative of this fx. When the derivative of the function is given 2x, we can say antiderivative of 2x will be infinitely many. All right, so what we are saying is, let's write it. We are saying because derivative of x squared plus c is equal to 2x, where c is any real number, this means integration of 2x dx. See, this is the symbol that we use for integration. This is symbol, and then we write dx, antiderivative or integration, right? So we can say antiderivative of 2x is, let's write antiderivative now only. We will use this symbol little later. So what we are saying is, that means antiderivative of x 2x is, let's write it here once again, antiderivative or primitive, antiderivative or primitive of 2x is equal to x squared plus c, where c belongs to r is any real number. Okay, now that is what we are saying. Now you are introducing the symbol for antiderivative or primitive. The symbol that we use for antiderivative is this. It's like elongated s, this is the symbol. And we are saying any function fx, integration of fx dx. Suppose this comes some function, another function we are writing by capital F of x plus c. Let's say if we symbolically we write antiderivative means this integration sign and dx, and that is equal to fx plus c. That means we have the function here. It's this function, its derivative must be this. Antiderivative of fx is capital Fx plus c. It means the derivative dy dx of, derivative means dy dx of that fx plus c, capital Fx plus c, right, is equal to small fx. So what we are saying here is, if we are given a function whose derivative is something, and then integration of that derivative is equal to that function. That's what we have written here. So symbolically, we write the integration with this elongated s sign, and then we write a function, then dx. And this symbol means integration, or we can also say antiderivative or primitive or integration. All right. So this is the symbol that we use, and we have geometrical interpretation. What is geometrical interpretation? Let's try to understand geometrical interpretation first a little bit. So this was a symbol. Now, what is the meaning of geometrical meaning of differentiation? Geometrical interpretation of indefinite integral first. We said if fx is equal to 2x, then its derivative is x squared plus c. Let's geometrically draw these graphs. Geometrical meaning means we are going to draw the graph of this function, x squared plus c. If you take different values of c, let's say c equal to 0, then your graph would be y equal to x squared. No, it's a U-shaped graph. We have learned how to draw the graph. Y equal to x squared. Our graph will look like this, U-shaped graph. It's not the perfect graph, but it will look something like this, okay? Now it can take different values of c. Let's take c is equal to 1. Then our graph will look like this. C equal to 2, our graph will look like this. This point would be 0, 2. This point would be 0, 1. This is vertex 0, 0, of course, vertex of this parent function, which is x squared. Now if it is x squared minus c, then our graph will be like this. If it is passing through minus 2, for example. And you see, this is a family of the graph which are parallel to each other. So the integration of a function, when we are integrating 2x and we are writing 2x dx is equal to x squared plus c, and we take different values of c and we get all these members. And how many members are there in this family? There are infinitely many members. You see, this is 1, 2, 3, 4 we have shown, and for the different value of c, you will get different members. You can actually draw these graphs and you can see for yourself that geometrical interpretation is this, that any function you are finding, actually you are finding a family of the functions whose graph are actually parallel to each other. You know, there are many graphs, they belong to same family. Here you can say x square family, and taking different value of c, and we're getting different members of this family here. Now again, let's talk about a little bit, when we are saying the derivative of the function, we were talking about what? The tangent. Suppose this is a function, derivative of function at certain point, this is a point, that means we are talking about tangent to this function, just a line that just touches this function. This is fx, the function here is fx, and this is tangent t. So derivative means this slope of this tangent, right? And whereas we have already explained that geometrically indefinite integral means a family of curves. Now indefinite integral represent geometrically a family of the curves. We have seen just before, like y equal to x squared, then x squared plus 1, x squared plus 2. For different values of c, we get so many functions. So whenever you are integrating something, means you are finding a family of an individual function. Okay. All right, so here we will see some properties of indefinite integrals. It says the process of differentiation and integration are inverse to each other. Yes, like addition and subtractions are inverse to each other. So differentiation and integration are inverse of each other. The second says two indefinite integral with the same derivative leads to the same family of the curve. Of course, if their derivative is same, they belong to same family. We have just c is different, and for the different c's, we can have a whole family of the infinite members. The third property, if you see, integration of fx plus gx, they are together inside the bracket. We can actually write them separately, integration fx plus integration gx, and then integrate them. The fourth property is if there is any constant, any constant real number, and that can be taken out of the integral sign, and then we can write it k fx be equal to k time integral of fx. We need to integrate only the function, not the constant. Constant can be taken out of that integral sign. And finally, the property 4 can be generalized for two terms, 3 terms, 4 terms, and in n number of terms. Suppose you have n number of terms and there are n constants, we can take them out constant. So these properties we'll be using in solving questions in this is integration. Let's now take some of our questions, I mean derivative that we know, and let's form few basic formulae of integration. Well, the most used formula in differentiation is we differentiate x to power n, okay, and the derivative of x to power n is n time x to power n minus 1. We have used it many times. Derivative of x to power n is nx to power n minus 1. So can we say, this means, can we say integration of nx to power n minus 1, and we use dx sign, is equal to x to power n, and of course we use a constant because in integration we are getting a family, right? So this constant c means there are infinitely many such functions. So whenever we find integration, we will use that arbitrary constant c. This is a formula of integration, but isn't it little inconvenient? Because see, nx to power n minus 1, I would rather like to find the formula for integration x to power n. So we will do little bit of variation here. Look, if you find derivative of d by dx of x to power n plus 1 divided by n plus 1. All right. N plus 1 being constant, it would be 1 over n plus 1 out. We learned the property 4 in the integration, that anything which is constant will be taken out. And then you will differentiate. Then you will differentiate x to power d by dx of x to power n plus 1 using the formula that is at the top here. This formula now, what happens is any exponent of x to power any number, whether it is an integer or a fraction, and when we find the differentiation, when we differentiate it, that power will come in front and we reduce the exponent by 1. That's what is happening here, isn't it? So let's do the same here. We reduced x degree by 1. So this would be 1 over n plus 1 times the power n plus 1 in front, and x to power n plus 1 minus 1 means n. Look, this and this crossed. So what I'm getting here, very interesting. Derivative of this function is equal to x power n. Can I write formula now? I can write formula x to power n means integration of this should be equal to this over here, should be equal to x to power n plus 1 divided by n plus 1 plus c. That's interesting, isn't it? So we derived the very first formula of basic formula for the integration, that integration of x to power n dx will be x to power n plus 1 by n plus 1, taking this help of the differentiation that we have already learned. So this is very first formula of the integration and very, very basic as well. Similarly, we are going to write few more formulae, like, okay, let's play a game. We know the formula of differentiation, d by dx of sine x. You must write it. That is the interesting point. While you are learning, you should write. Derivative of sine x is cos x, and in integration, that's right, derivative here, integration on the right. And now that means integration of cos x, and we write dx there, is equal to sine x plus c. So we are writing formula from right to left. So differentiation is left to right and integration is right to left, inverse process, isn't it? Now let's say that another formula, derivative of cos x. Look, in the differentiation, whenever you differentiate a function starting with c, trigonometric function starting with co means complementary, it's related to the complementary, so it's a negative always. The derivative of cos x is negative sine x. Okay, so it means to keep it in memory, because later you will be finding integration of cos x also, which is negative, which is positive. We have seen sometimes student little bit confused in there. So they need to just catch hold on one formula. And you say in finding derivative, whenever you find of a trigonometric function starting with CO, it is always negative. Be firm for that. And then I want to find the integration for sine x. So in this, what I am going to change is I want to multiply both side by negative. So derivative of negative cos x will be minus into minus. This will become plus sine x. Yes. Derivative of negative cos x would be plus sine x. That means integration of sine x dx will be equal to integration of this is this. So minus cos x plus c. All right, let's take the next trigonometric function, derivative of 10x. I think you know this very well, and derivative of 10x is sec square x. So what we are going to write is we are going to write it right to left. So sec square x dx, sec square x dx should be is equal to 10x plus c. Why we are doing c? Because the derivative of 10x is also sec square x. But if we are finding derivative of 10x plus c, c can be any real number, then also its a derivative is sec square x, because derivative of a constant number is 0. So for that reason, we always write c. Let's take 10x is sec square x. What about derivative of dy dx of cot x? Derivative of cot x is negative of c. It is co, starting with co, no? Negative of cosec square x. But I do not like to take negative sign in the formula. So what I'm doing instead, I'm multiplying this by both side by minus. So this become minus cot, and the minus into minus, this will become plus. We change the formula as per our convenience. So this becomes integration of cosec square x dx is equal to minus cot x plus c. Okay. And sine cos 10, let's write derivative of now dy dx of 10x. Next is sec x. That we know derivative sec x is sec x 10x, sec x 10x, and this will mean integration of sec x 10x, sec x 10x dx is equal to sec x plus c. Next, you see, what is the derivative of cosec x? All right, derivative of cosec x is, again, starting with the letter co. So it is negative of cosec x cot x. Well, to write formula, I want to make it positive. So if this is positive, then this should be negative. So let's write the formula for integration now. So we say integration of cosec x cot x, cosec x cot x should be equal to negative cosec x plus c. So this is the, from the derivative of all these trigonometric functions, we have derived integral formulae, basic formulae for the integration. Now, once we have derived all the trigonometric, let's take inverse trigonometric functions also. Let's take the derivative of dy dx of sine inverse x. Derivative of sine inverse x is 1 by square root of 1 minus x squared. Yes, you must be uh, aware. I mean, you must be clear with this formula. The derivative of sine inverse x is this. So in integration, what we are going to write, integration of 1 over square root of 1 minus x squared should be equal to sine inverse x plus c. All right. Let's see the another formula, derivative of dy dx of cos inverse x. And that is equal to negative of 1 by under root 1 minus x squared. And we would like to make the formula for the integration. And for that, we want change in sign. This should be, we will make it positive, and then this will be negative. We are actually multiplying both sides by negative 1. So now the formula for the integration will look like integration of 1 by square root, same as the above, 1 minus x square dx. We must write dx always with this integral sign, and is equal to, that is negative of cos inverse. Negative of cos inverse x plus c. Now let's take the next one, derivative of tan inverse x. What is the formula for the differentiation of tan inverse x? That is 1 by 1 plus x squared. That means integral of 1 by 1 plus x squared dx. Isn't it very easy to get the formulae from differentiation? Tan inverse x plus c. Well, let's get one more, dy dx of, after 10 we have cot inverse x, cot inverse x, and it is negative of 1 over 1 plus x squared. That means we can say integration of, let's make this positive first. So if this is made positive, this should be made negative, right? Multiplying by minus 1 again. So we can write 1 by under root, not under root, 1 by 1 plus x squared dx is same as negative of cot inverse x plus c. Look, I mean, these two formulae, sine inverse and negative cos inverse, same integral. And the tan inverse and cot inverse, same thing. I mean, when you have to integrate this function, you can say this is either tan inverse x plus c, or you can say either this is minus cot inverse x plus c. Both has the same meaning. Now we will write another formula for that. Do you know what is the derivative of sec inverse x? How many of you know it? Yeah, it is 1 by x. We write like this, modulus x under root of x square minus 1. Now, integration formula would look like this, 1 by x is square root of x square minus 1, and its integration should be equal to sec inverse x plus c. This is x, right? Sec inverse x plus c. And well, one more derivative, derivative of sec. Next is cosec inverse x. Cosec inverse x would be negative of 1 by x and under root of x square minus 1. We are using this formula directly. And well, we need to make it positive. We would like to have a positive sign here. So we make changes accordingly. We multiply by minus both sides. And then we get integration of 1 by. While you are watching, you must write also, because writing is 10 times more powerful than just watching. Yes. So this would be negative of cosec inverse x plus c. So these are some formulae. We also know, I have a few about the logarithmic and exponential formulae. Let's see that. Let's write them also. dy dx of e to power x. This is a function which is beautiful. So the beauty of this function is that it never changes. You know, it's like e to power x derivative is e to power x, and when you integrate also, integration of e to power x is also e to power x. And let's write the derivative of dy dx of log x. And derivative of log x is 1 by x. X should be written in like this. Derivative of, because we take log of the positive quantity only, you know, it's defined for positive real numbers only. So the derivative of log x is 1 by x. So integration of 1 by x dx. 1 by x dx will be, means integration of x to power negative 1, right? There you will not apply x to power n formula. Instead, you will write log of mod of x plus c. And well, do you have derivative of a to power x also? dy dx of a to power x. A to power x is equal to a to power x log a, is it? But to find the formula for integration, I don't want log a here. I just want to know the formula of a to power x. So for that, we are dividing both sides by log a. You divide here by log a, and you divide here also by log a. What do you get? This log a gets cancelled. So means derivative of this thing over here is equal to a to power x. In integration, the formula would look like this. Integration of a to power x dx should be equal to a to power x divided by, we are writing the formula from right to left, divided by log of a. So these are very, very basic formulae of integration that we would be using to integrate basic functions. And using these formulae, now let's group all these formulae together and write all these formulae together, so that one more time, so that you memorize them very well, and whenever you have to apply them in questions, you are very comfortable there. So these are the formulae we derived a moment back. So you must write these formulae in this way only: differentiation, hence integration. Now let's take a question. Integration by the method of inspection. Search intuitively for a function whose derivative is given function. So we will use our intuition here to find antiderivative. They are saying write an antiderivative of each of the following function. Just one. Cos 2x. Let's take the first part. And what do you know about cos 2x? Like whose derivative? Can you tell me the function whose derivative is cos 2x? You'll say, well, this is cosine, and the cosine should be derivative of sine. That means dy dx of, we are doing the first part, okay? Dy dx of sine 2x. Sine 2x is cos 2x, because derivative of sine theta is cos theta. And then again, because this is a function of x, 2x, no? Into derivative of 2x. What is the derivative of 2x? Derivative of 2x is 2. So it is derivative of sine 2x is 2 cos 2x. Can we write this 2 in front? Yes, because this is multiplied. 2 cos 2x. Derivative of sine x is 2 cos 2x. But we just want cos 2x. Means we are going to divide both sides by 2. I divide the left side by 2. I divide the right side by 2. This and 2 get cancelled. So what we are getting now? We are getting derivative of dy dx of sine 2x by 2 is equal to cos 2x. That means the antiderivative of cos 2x is, let's write here. Therefore, antiderivative. They are asking about antiderivative, no? Antiderivative of which function is that? Cos 2x. Cos 2x is sine 2x divided by 2. So part 1 is done. Can you answer similarly part 2? In part 2, they are talking about 3x squared plus 4x cubed. There are two parts. Can you think a function whose derivative is 3x squared? You'll say, yeah, that's fine. This is easy. Derivative of dy dx of x cube is actually 3x squared. Similarly, can you find a function whose derivative is 4x cube? You will say, yes, this is also easy, because 4 and x 3, that means this should be x to power 4. So derivative of x cube plus x4 would be, okay, simply differentiate it now. Derivative of x cube is nx to power n minus 1, no? 3x to power 2 plus 4x to power 3. That means this statements tell me antiderivative. This is the second part we are doing here. Antiderivative of 3x squared plus 4x cube is x cube plus 4. X cube plus x4. Okay, so the antiderivative of this second function is x cube plus x4. Can you try the third one, please? All right, you must be doing it like this because by intuition, we know the derivative of log x is equal to 1 by x. That means antiderivative. Antiderivative. This is, of course, just one of the infinitely many antiderivatives, right? We are asked just one, so we are writing just one. Antiderivative of 1 by x is log mod x. Okay, now e to power 2x, fourth part. For e to power 2x, let's see what is the derivative of e to power 2x first, because we know the exponential function e to power 2x, its derivative is e to power x is e to power x only. But since this is a function of x, this is not just x, it is the function of x. So we'll differentiate 2x once again. So derivative of 2x is 2. So we can say d by dx of e to power 2x is equal to 2 times e to power 2x. That means, okay, but we want only e to power 2x here, you see. So what we can do? Divide both side by 2. Divide this by 2. Divide this by 2. On the right side, this 2 and 2 gets cancelled. That means we get derivative of e to power 2x by 2 is e to power 2x. This means antiderivative of e to power 2x, antiderivative of e to power 2x is e to power 2x divided by 2. Once again, reminder, you have to write while watching to get best out of this. Okay, let's see the last fifth part now. Sine 2x, it has two parts. Let's consider them separately. Sine 2x, we know the derivative of cos. Sine is the derivative of cos. So let's see first that function only. dy dx of sine 2x. And this would be derivative of sine is cos. So that should be negative of derivative of, no, not negative. Derivative of sine is cos only. So this is cos 2x, and then derivative of 2x, that is 2. 2 cos 2x. Oh, we want sine, no? Just a moment. We want sine, so we will take cos. You know the derivative dy dx of cos 2x. Cos 2x would be sine 2x. And then by chain rule, you will multiply by the derivative of 2x, which is 2. But we are interested only in sine 2x. Divide by 2 both sides. So divide by 2. Sorry. Divide by 2. Divide by 2. This 2 is gone. Bye bye. So you have d by dx of cos x by 2 is sine 2x. Similarly, can you find antiderivative for the second part? You just consider the function derivative of e to power 3x. Now, what is the derivative of e to power 3x? Derivative of e to power x is e to power x only. Multiplied by 3 means you can write into here. 3 to power 3x. But we need 4. For that, multiply this by 4 by 3 both sides. Means you can now say dy dx of 4 by 3 e to power 3x this whole function. Its a derivative would be here on the right side, this 3 and 3 get cancelled. You get 4 e to power 3x. Look, we're getting this 4 e to power 3x and sine 2x. Can we write these function together now? Okay, we're going to write it here. What we are writing is derivative of d by dx of this function together. Cos 2x by 2, cos 2x by 2 plus 4. Is that plus or minus? It is minus here, no? Minus 4 by 3 e to power 3x. Derivative of this is equal to sine of 2x, which is this, minus that is this right hand side, 4 e to power 3x. 4 e to power 3x. That means we can now easily conclude, just like in the previous question, that means antiderivative of this function is this, right? So that's easy now. You can write therefore antiderivative of the function on the right hand side, which is sine 2x minus 4 e to power x, which is same as this question number 5, is equal to this value over here, this value, right? So this is the antiderivative of part number 5. So we are done with this question. Let's take one more question. Find the derivative of the function defined by this, where f0 is equal to 3. d by dx of x to power 4 minus 6x. Look, plus c, I'm saying c can be any constant which is not known. Because we are given here f0 equal to c, then we are going to find that that c using this later. So if you see, the derivative of this function will be derivative of 4x cube, 4x power 4 is 4x cube, minus derivative of 6x is 6, and this constant is 0, so it will be 4x cube minus 6 only, plus 0, no? So that means antiderivative, this means antiderivative, as we know there are infinitely many antiderivative of any function. Antiderivative of 4x cube minus 6 is a function there, x to power 4 minus 6x plus c. Now this function is what they are saying as capital F. Capital F of x is equal to x4 minus 6x plus c. We need to find c using this information. F0 is equal to 3. Can you use it here? It is c. F0 equal to c means if you put x, F0 equal to 3 means fx would be, the value of fx will be 3 if you put x equal to 0. So x equal to 0 means 0 to power 4 minus 6 into 0 plus c. This gives you 3 is equal to, this is 0, this is 0, so c. c equal to 3. The value of c is 3, satisfying this condition. Therefore, we can write our answer. Second, we can write our answer. Therefore, find antiderivative f means capital Fx would be equal to x4 minus 6x plus 3. All right, so that's all for now. So we have learned the basics of integration, very, very basic formulae, and finding integration intuitively by using differentiation. We'll continue with the questions in next presentation. Till then, take care and I'll see you next time. Thank you for watching. Bye-bye.